Excess limiting reactants, page 4 of homework packet 7B. Let's take a look at what we have here. And we have 50 ice cream scoops react with 30 cones to produce ice cream treats according to our equation. It's the same, 2 scoops plus 1 cone forms 1 double-decker ice cream treat. So you're going to be real inflexible and try to hold things to that particular uh, ice cream treat equation. So initially we have 50 scoops, and initially we have 30 cones, and we haven't made any treats yet. Okay, now we got to figure out the limiting reactant. Oh, well, it's the one with less is the limiting reactant. Not necessarily. If I look at this, 50 divided by 2, I'd have enough scoops to make 25 treats, where I have enough cones to make 30 treats. So the limiting reactant will actually be the scoops, even though it's a bigger number. Notice 2-to-1 ratio. What? If 2 is twice as big as 1, what number is twice as big as 30? It should be 60. So if I have 60, it's going to be the exact amount. If it's above 60, then the scoops would be in excess. What's a more systematic way to figure that out? Take the 50 divided by 2, you get 25. Take the 30 divided by 1, you get 30. The one with a smaller number is the limiting reactant. So I'm going to write that in right here, and I'll just put the LR right here by the scoops, and I'll put cones and say this cones is in excess. All right, all of our limiting reactant gets used. So if I have 50 scoops, I'm going to use them all up and put a 50 here. And because they're used, I'm going to put a minus sign. And if I use them all up, there are no leftover scoops. Okay. The next thing is 50. If I use 50 scoops, I'm going to use half as many cones because of the 1-to-2 ratio. So 50, the 2 goes on the bottom, the 1 goes on top. 50 times 1/2 leaves me with 25. And put a minus sign because we're using it. They're consumed. Thus, the 25 plain cones get converted to ice cream treats. And notice 2-to-1 here, it's also 2-to-1 here. So the number of treats is going to be 25, except these are going to be things produced. So I ultimately take my 50 scoops and I use them, combine them with 25 cones, and I make 25 double-decker ice cream treats. How many cones do I left over? Plain cones do I have left over? Well, I started with 30, I used 25. So it looks like I have 5 left over. And how many treats did I make? I made 25. So I think we got all our questions in the box. Okay, our ice box right here. But let's just think outside of the box and put our questions, answer our questions there. So what's the limiting reactant? We said it was the scoops. So I'm going to put scoops right here. What reactant is in excess? How much is left over? It looks like it's 5 excess cones. See if we can spell that right. And let's draw where we got that information. So this is your excess cones right here. And then how many ice cream treats? It would just be this number 25. So I suppose I'll type that in. 25 treats right there. Okay, so that is an excess limiting reactant with scoops and cones. But when it was interesting, the one that had more scoops, it was still the limiting reactant because it wasn't twice as big. Let's look at that with a chemical reaction and make that comparison right here. I'm just going to slide down, I think. Let's try this. Clear out, slide down. Look at this problem, and I don't know if I can fit it in, so I'm going to make this a little smaller. Okay. So then what is the limiting reactant? Oh, I got 100 and 960. However, these are in grams. And this equation does not compare grams. 2H2 plus O2 forms 2H2O. It does compare moles. So I need to convert my grams to moles before doing anything. And what I'm going to do is take this, I'll do it right up here, and take 100. That's not 100. Let's try that. Grams. And I'm going to divide that by 2 grams per mole. So I'm going to kind of do it shorthand. I'm going to divide that by 2 because the molar mass of H is 1, but H2 would be 2. And mass divided by molar mass equals, and I'm going to get 50. Maybe I'll save a little space here. I'm going to get 50 moles right here of H2. That's something I can compare with this equation. I'm going to do the same thing with the oxygen here. And I'm given 960 grams. I'm going to put it over 32 because oxygen is 16, but O2 would be 32. And I believe that's going to equal 30 moles right here. So technically, this is this 30 moles right here. This is going to be 50 moles. Just like 30 scoops and 50 scoops like we did in the last problem. All right, I'm going to put a little bit of writing here. I'll put an I right here for initial, a C for change, and an E for end. That spell ice, the initial change in end. And I can start writing in some of these numbers because we said this is 50 moles. So again, we have 50 moles to start, 30 moles of oxygen. We don't have any water yet because we have not done the reaction. Okay, so it's kind of like the ice cream example, except we're dealing with the hydrogen, oxygen, and water right here. Okay, next thing is I got to find my limiting reactant. And let's see, I think I can do this up here. I might just delete this one thing and hopefully not delete a bunch of stuff. Let's try this. Okay. I'm just going to put this more up here and take this 960 divided by 32 equals 30 moles. Kind of ran out of space here. Okay, now a couple ways I could do this. I could say, hey, 50 is supposed to be twice as big as 30. It's not, so H2 is a limiting reactant. That's an inspection method. That's fine. Kind of the sure way to do this is to take this number 50. I'm going to go 50, divide by the coefficient of 2, and that equals 25. So this 50 divided by 2 equals 25. And then I'm going to keep going, and I'm going to say 30 divided by 1, because there's no coefficient, it's the implied 1, equals 30. So whichever number is smaller is going to be your limiting reactant, and that is the H2. So 25 after dividing through by a coefficient is smaller than 30. So H2 is the LR. I'm going to squeeze that in down here. And then O2 would be in excess. So I'll do a little excess here. Try not to smear my letters as I do that. Okay, all of your limiting reactant reacts. So if this is 50, this is going to be 50 right here, except it's reacting. So I go negative right here. And if all your limiting reactant reacts, you end up with nothing. Okay, if I have 50 here, half as many moles of oxygen are used, 50 times 1/2, but it's a reaction, so I'm going to say it's 25, but I'm going to put a negative in front because it's getting used up. So if we started with 30, we used 25, we are going to have 5 left. And yes, this is all in moles. And the last thing is notice it's a 2:1:2 ratio. So if 50 are used, 2:2 ratio, 50 of water are formed. So I'm going to say this is a 50, no negative sign because that's formed. So this would be the moles of water that are produced right here. Okay, let's look at this. What is the limiting reactant? The limiting reactant we said was the H2. So I'm going to write that in right here and OH2. What reactant is in excess? How many moles of it are left over? I'm going to say 5 moles excess, and that would be O2. Where am I getting that from? I'm getting that from right here. We started with 30, we used 25, we're left with 5. And then it says what mass of water vapor is needed. I don't just want to write 50 because that's moles. Okay, so I'm going to do what? 50 moles, and then I'm going to times that by the molar mass, and the molar mass of water is 18 grams per 1 mole. So essentially 50 times 18, and trying to do the quick math here, I think that ends up being 900 grams of H2O right here. Okay, let's try this. H2O. Try one more time. I think we got it right there. So just looking back at this problem, if you're given grams like we have here, convert to moles. Now you can compare them in the equation. Look at your initial, use your ice box. You have 50 here, 30 here, nothing here. And you determine your limiting reactant either by inspection, saying 50 isn't twice as big as 30, so that's limiting reactant, or just taking the 50 divided by its coefficient, 30 divided by its coefficient, the smaller number is the limiting reactant. All your limiting reactant gets used. Figure this out based on the ratio. 50 times 1/2 is 25. 50 times 2/2 is 50. And then for the excess reactant, the initial minus 25 gives you 5. And the total amount of product is right here. All right, good luck. And now you can start some of the problems on the next pages. Thanks for watching. And remember to subscribe.